Welcome children. Today we shall start with the pairs of lines. In pairs of lines, first we'll take up intersecting lines. Okay. Now L and M are two lines which meet at common point O. So these lines L and M are called intersecting lines. So how do we define intersecting lines? Two lines which meet at a common point are called intersecting lines. Okay. Now second in the list is parallel lines. How do we define parallel lines? I will draw two lines. This is line L and this is line M. These two lines are drawn in such a way that this distance, vertical distance between the two lines is same. Okay? So we define parallel lines as if the distance between two lines is same throughout, they are called parallel lines. Okay. Now the third one comes the transversal. Now see what is the transversal. I am drawing these two lines. This is line L and this is line M. Okay. Now these two lines are cut by a third line. This is cut by a third line T at distinct points. Then this line T is called the transversal to these lines L and M. In this figure, lines are L and M and transversal is T. You must remember that this is the transversal, means two lines are there, so there must be 2 points of intersection. If we have 3 lines, then 3 points of intersection must be there. So if L and M are cut by a third line, this line is transversal if it intersects these two lines at these 2 points. So we will define transversal as the line that intersects 2 or more lines at distinct points. Then that line is called the transversal. Got it? Now let us see few examples. See here. In this case we have lines are L and M. We have to see whether P is transversal or not. Now see, line L and line M. This transversal P is intersecting these two lines at only one point. So we will say that P is not the transversal to lines L and line M. So P is not the transversal to lines L and M because it is intersecting these lines at one point only. Understood? Now see the second case. In the second case, we have 3 lines. L, N and N. L, M and N. L is here, M is here and N is here. Now we have to see whether P is the transversal or not. Now what is the condition? If P is the transversal, we have 3 lines, so there should be 3 points of intersection. But what do we observe here? Only 2 points of intersection. So here P is not the transversal to lines L, M and N because it is intersecting these 3 lines at only 2 points, and the points are this and this. Now coming to the third part, lines here are L, M and N. We have to find whether P is the transversal to lines L, N and N. So this transversal P intersects lines L, N and M at 3 distinct points. This point and this point. So P is the transversal to lines L, N and M. Now try these. Let us see. First one, we have to find an example from the surrounding where lines intersect at right angles. So you see the blackboard. This is the blackboard. Now you see here, this is intersecting at right angles. So this is one of the example. Okay. Now coming to question number 2. Find the measures of the angles made by the intersecting lines at the vertices of an equilateral triangle. Now these are, see, I have these 3 lines L, M and N, and I have formed an equilateral triangle. What is the equilateral triangle? Length of the 3 sides are equal. So this is an equilateral triangle. Let us take the protractor and measure it. The measure of this angle is 60 degrees. See here, this is 60 degree. Now if we measure again this angle, this one, this again comes out to be 60 degree. Similarly, if you measure this angle, this also will come out to be 60 degree. So we conclude that the angles made by the intersecting lines at the vertices of an equilateral triangle is 60 degree each. Now the next question, draw any rectangle and find the measures of the angles at the 4 vertices made by the intersecting lines. Now this is line L, this is line M, this is line N and this is line P. These lines are made in such a way that a rectangle is formed. Now we place at one of the vertex this protractor and we see that a 90 degree angle is formed. Similarly, you place at this vertex and you see that again a 90 degree angle is formed. So when you place it here and here, you will get 90 degree. So the measures of the angles at the 4 vertices made by the intersecting lines is 90 degree. Understood? Now let us come to the next question, question number 4. If you are given, if two lines intersect, do they always intersect at right angles? See, these are two lines, so they do not intersect at right angles. This is not a right angle. Now another case. So here these are the two lines, they are intersecting at this point and this angle is 90 degree. So we say that two lines do not always intersect at right angles. Yes, question number 5. Suppose two lines are given. Let us draw two lines. L and N. How many transversals can you draw for these lines? We can draw so we see we can draw any number of transversals, say T1, T2, T3, T4, T5 and so on. So we can draw infinite number of transversals to the two given lines. Alright. Now coming to the sixth question. If a line is transversal to three lines, let us draw three lines. Let us draw the transversal T. How many points of intersection are there? 1 point, 2 point and 3 point. So we get 3 points of intersection. Lines are L, M and N. Another case we see. Here the lines we have drawn parallel. Now let us draw three lines like this. Let this be line L. Let this be line M. And let this be line N. So let us draw the transversal. This is line L. It should have 3 points of intersection, so we will draw the transversal like this. See here, this transversal is cutting line M at this point, line N at this point and line L at this point. So we say that T is the transversal to lines L, M and N, and 3 lines and 3 points of intersection. Here 3 lines, 3 points of intersection. Now the third question, try to find a few transversal in your surroundings. You must have seen the windows, grills are there, something like this, So see here, these are the parallel lines and this is the transversal. This is the example of transversal to parallel lines.